Ew.
What up?
How y'all doing today?
I want to teach you. We want to teach you about something that's the same,
But different.
But it's still
That'd
the
be
same.
us.
Yeah,
Maybe us, because we the same.
we're the same, but we're different.
Oh, but we're different.
That's right,
Yo, we're allotropes.
bro. Allotrope, bro. Ah!
You are a carbon-based life form.
Target.
Oh.
Don't do it,
Sigh.
man.
Sorry.
So you need to be able to describe what an allotrope is, and again, know the 7 diatomic elements. So we're beating a dead horse, but that's the point.
Well, because there's some horses need to be beaten.
Allotropes of carbon. Did anybody got anything to say about this?
I bet you Nardos.
Except my homeboy Sugalos from Ancient Aliens. It's the same, but different.
So everything you see there, diamond, graphite, fullerene, and soot, are all made of carbon. They're just put together in different ways.
Yeah, it's like the same Lego set, but you can make lots of different stuff with it.
Yeah, you can take the Legos apart and rearrange them and make a battleship, and then rearrange them and make a castle. And take them apart, rearrange them, and make something else.
Yeah, and this is kind of connected to allotropy because the only atom present in each of these samples is carbon. It's just how they're connected in single plane sheets, in complex, soccer ball type shapes, tetrahedral arrangements to get the diamond, or the soot, which is just like billions of particles of just
Yuck.
crappy carbon.
Correct. So really, that's all you need to know is that allotropes are same stuff, only different. So sulfur, there's many different variations of sulfur.
White sulfur is like explosively dangerous in oxygen. Red's not so much.
Not so much.
And from the looks of black sulfur is pretty dangerous too and not very common.
Yeah.
It's like in 2 different jars inside of a sample over there. Like,
Yeah, right.
Keep that stuff away.
Yeah. And then it also can arrange itself very flat, or it can get in a very 3-dimensional shape, as you see in the picture.
I guess I should have read the details about white phosphorus. It's volatile. It glows with a white light and spontaneously bursts into flame. Melts at 44.2 degrees Celsius. So it gets hot, it's going to melt and then burst into flame.
Nice.
The other ones didn't do so much.
Right. So this is what you really got to know. Ready? Go ahead.
It's the same, but different.
But different.
Yeah.
Good thing we're not doing a lesson on fingers.
Mm.
Inside joke.
They call them fingers, but I ain't never seen them fing.
We're getting there. Each of 2 or more different physical forms of an element can exist. Same element, different arrangement. So here's the nutshell. Ready? I'm not going to read it verbatim. What it's saying is that if I take the same stuff, put it together differently, I'm going to act differently and have different properties based on how it's put together, not based on what it is.
There's microscopic properties for the single atom, carbon, for example. Every one will behave the same way. And then there's macroscopic properties from the structure that those carbons made. Big. Yeah. So like put them all together in a certain way, you get different properties.
Yes.
Graphite's great for writing with, not so much great for giving on wedding rings.
Right. Yeah, and you can tell they definitely have different properties because diamond is one of the hardest materials we have on the earth.
And it's clear.
And it's clear and it's hard. And have you ever broken a pencil tip before?
All the
Not so hard.
right. And
Not
definitely not clear either.
Definitely not cutting glass with the tip of my pencil.
Right.
Right? So
That'd be
different
pretty
properties.
rad, but that's not going to happen.
Not happening. So different properties because they're arranged differently in space. Allotropes, definition you need to know. Do you think it's testable?
Definitely.
We wouldn't have made 16 videos about it if it wasn't.
Yeah.
Oh.
Speaking of testable things.
Yeah. This is one that really you need to have this down if you haven't figured that out yet. Okay.
Yeah.
Special elements that exist as 2.
Yeah.
There they is. Oh. How do I remember them?
I remember them with the Hofbrinkel. Hydrogen, oxygen, fluorine, bromine, iodine, chlorine. Nitrogen, and then the chlorine. Yeah. Hofbrinkel. Don't forget the end.
Or you can remember the 7H club. Remember, at element 7, I make the letter 7. Or the number 7. I said letter 7. That ain't going to work. The number 7. It's been a long day. Add in hydrogen, and then you get... You have any coffee?
7H Club. No, I
You have
don't
any
have
coffee?
any coffee.
I can use some more coffee.
Go make some
Can I
coffee.
have some more coffee, please?
gosh. You know, I honestly, guys, I think this is actually recording me while I'm doing this.